Physics 10th grade, class 79 solutions, Minerva Bilingual School. Let's do this. All right, guys, so let's talk about this worksheet. Let me get my laser pointer real fast. Laser pointer. All right, so what I did here is we already talked about the answer to 1A, right? So I put that, just a copy of what we did in the last video, the class 79 video. There's the solution there. If you want to know, once again, how we got this process, go to the class 79 video. I also put all the formulas that we talked about last class right here, because we're going to need to refer to these on basically every problem. I think every problem. And also on this next page, you guys will see that I also put the official answers from NASA. And so you guys will see at the end of this video, we will have every answer that NASA has. And there you go. So let's do this. Let's not waste any more time. Let's get started. So let's look at 1B. If the input piston has moved 4 inches, how far has the output piston moved? So when I see this 4 inches, I'm thinking distance, okay? Distance. So vertical distance the piston has moved. So I'm looking for a formula with distance. Look at that, D1 and D2 right here, right? And let's see, now they want to know basically what is D2, because we know that this 4 inches is D1, right? So how do we find D2? We have to use some information that we already have. So I see that we have a formula with D1 and D2 here. But what else do we also have? We also have A2 and A1. If you remember from 1A, we found A2 and A1 right here. So we're going to use both of those values in order to find D2. So A1 is 0.785 inches squared. Before I write the area, we're going to copy this formula. So D1 over D2 equals A2 over A1. D1 over D2 equals A2 over A1, like that. And that is exactly correct. So now let's fill in all the information that we know. Like I just said, D1 is 4 inches. So we're going to say 4 over D2 equals A2, we know from part 1A. A2 is 28.274. Right, 28.274 all over A1, and we also know A1. Sorry that I'm moving around the screen, moving the screen around so much. This is 0.785 inches, so a little less than an inch, 0.785. All right, 0.785. All right, now I'm not going to go through the whole cross multiplication process because we've done that a trillion times this year so far. So I'm just going to do it in my calculator, and you guys should know how to get D2 when we're here. So 4 times 0.785 divided by 28.274, and I get 0.111, okay? And we're talking about D2, so this is going to be inches, right? So there's our answer. Now let's compare with NASA. You're going to see that NASA's answer in the beginning looks different, but it's actually not. So they said, oh, they didn't say 0.11. They said 1 over 9. But do 1 divided by 9 in your calculator. What do you get? 0.111. Right? So, 1 over 9 is the same as our answer. So there you go. All right. So you can say, if you want, you could say, or 1 over 9. Okay? I'm happy with either. This is close enough, and it demonstrates that we did the correct process. All right, sweet. Number 1 is finished. Let's look at number 2. A hydraulic system is said to have a mechanical advantage of 40. Mechanical advantage equals FR over FE. Okay? This is the same as saying F2 okay? F2, and then FE, they're calling it force input, but FE is referring to what we call F1, okay? So this that formula, if when they say mechanical advantage is FR over FE, they're saying mechanical advantage equals F2 over F1, which is, interestingly, the same formula that I gave you guys last class. Right here, you can see the mechanical advantage, and then the F2 over F1, same thing, okay? Cool. Now, they say the input piston, if the input piston with a 12-inch radius has a force of 65 pounds pushing downward a distance of 20 inches, find, now they give us lots of things to find. Number one, let's find the volume of fluid that has been displaced. Okay, when I see them say volume, I think, we need to use the volume formula, which we know from last class. Pi r squared times height. In this case, we're going to call height d1, and they give us r squared, they give us r, and they give us d, which is everything that we need to know to find the volume. So we're going to plug in the formula. Volume 1 equals pi times, there's the radius 12 squared, times d1 they give us. It goes a distance of 20 inches, right? So times 20, like that. Plug into your calculator. I like to do the, if I see the squared, I mean, you could say pi and then parentheses 12 squared, close the parentheses, times 20. What I like to do is go 12 in my calculator, square the 12, obviously 144, and then times pi, and then times 20, and you get 9,047.786. Now, I'll tell you right now, when the NASA, whoever, the worker, it says their name actually on the website, when they did it, they actually used 3.14 for pi, probably just to save time. They decided to approximate this number because we know that pi actually is 3.141592654, I think. What's the where I got? I'll just do my calculator. Pi, I'll read it to you. 3.141592654. Yeah, but they just used 3.14. So if you use 3.14, let's do that again. 12 squared, obviously 144 times 3.14, and then times 20, and you get 9,043. If you approximate pi as 3.14, 9,043. Now we're talking about volume, so this is inches cubed. I got really 9,043.2, but they approximated their answer to be 9,043, and you will see here 9,043 cubic inches. Boom. We agree with NASA. You guys should be proud. All right, 2B. Next, we need to find the upward force on the output piston. That's referring to F2. Okay? I think that 2B is probably the easiest problem because we can use this formula that we just talked about. The MA equals F2 over F1, because we know that MA, mechanical advantage, is 40, and we know F1 is 65, so we can use that formula to find F2. So 40 equals, I think I said 65. Yeah. Now, let me look at the formula one more time. F1 is on the bottom. So F2 divided by F1 is 65, right? So it's like saying 40 over 1. Cross multiply, and you get F2 is really 40 times 65, 2,600 pounds. 2,600 pounds. You know it's pounds because they're asking about for force. Right? Let's check with NASA. 2,600 pounds. Just like that. All right, we're going fast. Let's see how long we've been going for. It's been 9 minutes. You guys are going to have a nice and short video today. Next, we need to find the radius of the output piston. All right, radius of the output piston. So let's think about this. We know both forces, F1 and F2. We also know the radius of the input piston is 12, right? So we only need to find the radius of the output piston. So let's look at our formulas. And I'm thinking, what formulas could we use? We know F2, F1, and really we can find A1. Why? Because A1 only depends on what? The radius, right? So we know the radius of A1 because they tell us it is 12, right? And in order to find the radius of A2, we can use this formula because we know that A2, another way to say that is pi times radius. The area of A2 is pi times radius squared, right? So we can use that and plug it in for A2, and then we can solve for R. And this is R2, right? R2. Boom. So let's plug in what we know. We're going to use these four and cross multiply all those. Okay. Actually, I'm going to leave all that there. All right, A2 over A1. A2 over A1 equals F2 over F1. Okay. We know we don't know A2, but we're going to call, instead of saying A2 right here, we're going to call this pi times radius 2 squared. So we can find that radius. All over A1, we know is, we know the radius. So we're going to say pi times 12 squared. Pi times 12 squared equals F2, we just found, is 2,600 pounds. All over F1, we already know they gave it to us, equals 65, just like that. Okay, so now let's cross multiply. What I would do if I were you is simplify all this. So I guess I'll draw this part. I'll write out this part for you. So when you simplify the left, you're going to get pi r squared over 144 times pi. You get 452.389. 452.389 equals 2,600 all over 65. Cross multiply, cross multiply. Right, so really so we'll do these two multiplied first. We'll go 65 times pi times radius 2 squared equals, now I'm going to multiply these right now and get a number. So 452.389 times 2,600. Should have put a comma there, but that's not biggie. We get 1,000,000. I'll write this out. We get 1,176,211.4. That's what we get on the right. So now we're going to do, now we're going to solve for R2. So divide both sides by, if you want, you can multiply these and then divide both sides by that product. Or, what I typically do is I'm going to go divide by, it's going to be easiest to explain if I just, you can divide 65 and then divide pi and then square root, but I'm going to multiply 65 and pi. 65 times pi, because it's easier to explain. So 204.204 about times R2 squared equals that big number, 1,176,211.4. All right, now divide both sides by the 204.204, like that. So let's cancel. Divide by 204.204. So you get R2 squared equals, let me do this division. 1,176,211.4 divided by 204.204. You get on the right 5,759 point 982. You guys will see that I typically am going 3 decimals out. Yeah, I mean, the more decimals you go out, the more accurate your answer will be. But when we're talking about rounding, if I have not given you specific instructions to round to a certain, to a certain amount, like tenths or hundredths or thousandths, I mean, error on the side of rounding, like by putting more numbers instead of, if you round, for example, to the nearest whole number, your answers are probably going to be a little bit off. All right, so now we're going to square root. Square root, you get R2 equals square root of that big number. You get 75, 75.89 about. And radius is referring to inches. It's a distance, right? There's our answer. Now our answer could be a tiny bit different than NASA's because you guys see that, like, I chose to round to the nearest thousandths there, and then here I rounded to the nearest tenths. I think that's because it only went to the tenths right there. That's why I didn't put more numbers. But if our answer is a tiny bit different, it's no big deal. It's because of rounding, not because of incorrect process. Oh, look at that. Our answer is 75.89. So if you round this to the nearest tenths, you get 75.9. And look at NASA's answer, 75.9. So we're good. All right, last question, and then we are done with this. And then I will expect your emails tonight before 11:59 p.m. with, you know what? It says it in the instructions. Yeah, here, let me show you on on Google Classroom. I say Khan Academy. Let me show you real quick because I talked about the homework, what you're going to email me. So you'll see that here's the instructions. I'm recording this obviously not when you're watching this. Right now it's 9:34 on Wednesday night, but here's what you will have read the next day. Homework rules, very specific rules. I will tell you right now, read this entire thing carefully. If you don't, then you're gonna have problems. I'll just say that. Cool. All right, last one. We want to know the distance the output piston moves. Okay, so let's see what formula we could use to find the distance the output piston moves. Well, look at this. The easiest one I think to do to find the distance the output piston moves is, let me get rid of all these little lines, all these circles, all these ovals. So we already know D1 right there because they gave it to us, 20 inches, right? There's 20 inches. Now we need to find the distance the output piston moves. Output is referring to D2. And look, we already know both these forces, right? So we could take this and the forces and say D1 over D2 equals F2 over F1, like that. And with that formula, we can super easily find D2. Okay. D1 over D2 equals F2 over F1, like that, right? Okay. D1, I think we said it was 20 inches. 20 inches, yeah. All right. 20 inches over D2 equals, we know F2 is, we found it before, 2,600 over F1, they gave it to us, 65 pounds, right? Cross multiply all this. I'm not gonna do this whole process like I said before. So cross multiply, and you get D2 is 0.5 inches. All right, so there's our answer. Let's corroborate with NASA. And look, D2, they even went through this. They wrote more than they needed to, but there's the answer. D2 equals 0.5 inches. So, sweet. Guys, that is everything. See you next class.